Thanks for everyone tuning in. I'm just so excited to be here. This is my first time participating in a .NET conference, so bear with me. I'm going to do my best to answer your questions. Please keep them coming, and if I can't answer them, I'm going to look to Dan and team, and then I can also look back to my team and make sure you get your questions answered, because that's almost as important as seeing new stuff and getting excited about new stuff. And I'm going to take it kind of up a level from the previous session, and I was trying to think about like what my goal was for this, next 45 minutes that I have with you all. And I think the goal is really just to kind of inspire, invoke, like get you guys motivated about things that are possible with your .NET knowledge, like things that are going to be easier even when you talk about doing things that maybe aren't as familiar as to you, and some of these things are familiar to you depending on who's tuning in. But I'm going to be talking about some ways you can piece things together. So how you can take a scenario and kind of piece it together with different services. And just a tiny bit about me. My name is Anna Hoffman. I think that was mentioned already. I'm a data and applied scientist / program manager. So maybe not your typical .NET developer. I've worked at Microsoft a while. I started working on integrations and samples for .NET with Cognitive Services, and now I work on the Azure SQL team at Microsoft. So you'll see some slants towards Azure SQL Database, but I'm going to try to keep it relatively neutral, product neutral, and just show you some cool stuff, show you how to connect some things together. And I have all of this in a code sample, which I'm still working on making the documentation for it a little bit better, but I do have the code sample ready to share with you guys. So I'm going to stop blabbing and just go ahead and get right into it. So I want to talk about a scenario that is very typical for most people, regardless of where you live. And just a little bit of background, of course, this might be less applicable now that a lot of us are working from home, but remember the days when you used to take the bus to go to work, and the scenario is this. So you go to the bus stop, you take the bus, you go to work. Very simple, very straightforward. However, more often than not, I would anticipate two things happen. The first is you go to the bus stop, the bus isn't there, and you don't know when the next bus is coming, so you have to wait, 15, 20, 30 minutes, depending on how frequently your bus runs, and then you get to work. Maybe you're late, maybe you have to take that meeting from the bus, some things that are not ideal. Now, the other scenario that has happened to me quite often is I go to catch the bus, I see the bus, I run to the bus, I still miss the bus, and I have to wait for the bus, and I'm now in this same scenario as before, and it's just not ideal. So myself and a colleague, Davide Mari, we said, okay, let's come up with a way to make it easier to catch the bus, because this is something relatable, and you'll see we tie in a lot of things, and I think it's applicable to a lot of scenarios, but that's kind of what we're going to be doing in this session. We're going to go through catching the bus in a great way. So we live in a day and age where most of us have smartphones. So imagine that you had your smartphone and you could go to a website and see where the bus was. And you could even get notified when your bus was close to you. So using things like geospatial and geospatial points and geometries and collections, we could try to figure out when the bus is close to you or close to the bus stop you want to take. And then you can leisurely walk out to your bus, catch the bus, and go to work. No stress, no waiting for the bus, no late, anything like that. So that's what we're going to try to do today. This is kind of the first time I've done this as a scenario where we're just going to follow the scenario through the whole thing and kind of feed in technology as it makes sense. Again, if you have questions throughout, please go ahead and throw them in the chat where you're streaming from. I am trying to keep an eye on those. And if I don't get to it, we'll talk about it at the end. Okay, so the first goal is, okay, what about this data? Where are we getting this data from? Well, it turns out, and so I'm going to do this for Seattle, the Seattle, Washington area in the US. This is called King County. This is right by Microsoft's campus. But basically, a lot of big cities, I would say most big cities, make this data publicly available. And what it is this. There are two main sources. One is a flat file, and this just contains some route information, route reference type of data. And the second is a JSON file with the GTFS format, which is a very common format for storing real-time location information like this. And it's basically a real-time file. So you can call it, you get a new file, new data points in it, all stored in JSON. And then, so we have this data set that we can use. And the idea is we can kind of develop this microservices architecture. The idea here is to just to break apart some of the services required and use them to create different things. So in this case, we're going to create a few services and use some for a web application and use some to create notifications. So you can get a notification when your bus is what we're going to call in a geofence. And I'll talk more about that when we get to it. And then a little bit of a marketing slide here, but I just want to show you why I am going to use Azure here for all the different pieces. One, there are just options regardless of what I'm trying to do, whether I want VMs, containers, platform as a service, or low code services. Those are here today. Some of the services you're going to touch on today include Azure Static Web Apps, Azure Logic Apps, Azure Functions, which all fall into that kind of like serverless category. You'll also see there's some low code options, but I'm not using those as much today because this is a .NET conference. And then we also have lots of managed databases. Again, me coming with bias, I think Azure SQL Database is going to be the best one for this scenario, and I'll tell you a little bit of why. And they also have a serverless option, which we'll talk about a little bit later. And then, DevOps is very important when we talk about the life cycle of our applications and application development. So we'll also talk about GitHub Actions and some integrations with Visual Studio Code in .NET. But also if you're writing other languages, we're kind of in this space where, people write whatever language is easiest for a given task. So I'll show you some ways to maybe start learning other languages because I have the same code sample in Node as well as in Python. Okay, so that's what we're going to be doing today, kind of a really big overview. But I wanted to start by talking a little bit about the database choice. Many of you are probably familiar with SQL Server. It's known as this years old enterprise level SQL engine that is used by many big companies around the world. But when we went to Azure, when Microsoft started moving into a cloud-based organization, we came up with 3 deployment options for basically deploying SQL Server in the cloud. And just to cover them super briefly, the first one is SQL Server and Azure Virtual Machine. This is exactly what it sounds like. It's just SQL Server running in a virtual machine. So all of the things you do to manage your SQL Server, you still have to do. We're just taking care of the infrastructure and the hardware. You still manage the OS and the SQL Server, so picking the version, upgrading, SQL agent, all that stuff is going to be on you, as well as picking the OS. So if you want to run Linux or Windows, we have different versions of like Ubuntu, RHEL, and SUSE Plus available for you. Now, that was infrastructure as a service, but we also have 2 more managed services. And when I say managed, a big part of this is like we take care of managing the availability of it and in many cases, the security of it and other things, as well as it being versionless. So you never have to upgrade again. We're just going to keep you running on the latest and greatest software. We're going to update you, add new capabilities without giving you really much of any downtime. Now, there's 2 options here. For SQL Server people moving SQL Server applications, Azure SQL Managed Instance is a great option because it's basically a managed SQL Server. You get all those instance scope capabilities. But for new applications, for modern applications, I really think Azure SQL Database is the way to go. And we have some options we're going to talk about today, like serverless and hyperscale, which you hear a lot when you think about applications, but maybe not as much recently when you think about the databases supporting those applications. So let's talk just a little bit about Azure SQL Database and why it's going to be best for this scenario. Now, I talk to a lot of people and they say, SQL Server is great, Azure SQL Database is great, but I don't want a relational database. And I think, and again, my bias coming in here, but I think at the root of it, the relational engine is really the backbone of many things because this is going to give you the ability to formally analyze, rewrite, and optimize queries. So apart from the obvious support that a relational model like SQL database is going to provide, like tables, columns, joins, predicates, indexing, that sort of thing. SQL DB also has multi-model capabilities, and that's what we're going to look at today. So things like native geospatial support, support for Json, and even some cost optimization things. So we're going to look at all those things today, and hopefully have like a better understanding of how Azure SQL Database is going to make your development actually easier. I think Chris was the one in the last session who mentioned, you know, writing less code means less room for finding bugs, and that's kind of where I think Azure SQL Database can help with development a lot. So let's talk about a few things. We'll get into a demo. Now, the first thing I wanted to call out is Json. Json is huge, and a lot of people don't realize that Azure SQL Database actually does support Json. And the really cool thing that it does, and you can kind of see it on the screen, is that it has some built-in functions for JSON queries, JSON values, is it JSON? But what's really interesting to me, at least, is that it has two capabilities to basically convert from JSON to a table and from a table to JSON. And you can kind of see how that's done here with open JSON and for JSON. So these are things that are going to be applicable for our catching the bus scenario, because all that data coming in as JSON. Now, the other piece of this is geospatial support, and Azure SQL Database does support this, and we're going to take a closer look at how this actually works. I'm not going to talk about too much here. I'd rather just show you all. So if we think about the architecture, we've talked about it so far. Ideally, we have this bus using some sort of IoT device that's collecting this real-time data. Somehow we got to get it into Azure SQL Database. We'll get to that soon. And then the route reference data, which is the flat file, we're going to pull that in using T-SQL. And then we'll have kind of our database set up. So now I just want to show you an example. This is kind of a smaller example of how JSON and geospatial is supported in Azure SQL Database. So let me hop screens. Hopefully you can see this, and I apologize, I might be looking slightly off camera for this because I have a few monitors up here. So this is another tool that's kind of cool. If it looks like Visual Studio Code, that's because it was forked from Visual Studio Code. This is Azure Data Studio. This is a great open source cross-platform tool for working with databases wherever they're located. But what you can see here is I have kind of an Explorer view. This is that sample I was talking about. I'll share. I'm going to hide this for now. The other thing I find really interesting is these notebooks. And if you've seen any data science things or been up with notebooks, this was something used for data science for a very long time, but they recently added new kernels for example, Sql, Powershell. I'm a big fan of the Powershell one too. I use that one pretty often. And these notebooks are really great because it allows you to combine text cells with code cells, and you can kind of store the results. Now, I'm not going to go through this one that much, but I did want to say, like, basically we imported that flat file using Azure Blob Storage. It was very easy to do. I shared this notebook so you can basically connect it to your blank database, run through this notebook, and now your database is set up for this scenario. Again, not going to go through that one, but what we are going to talk about is some of these modern database capabilities in Azure SQL Database. I'm just going to make that a little bit bigger. So the first thing we can do is connect to the bus DB. So what I have is I basically have this bus server, and we want to connect to the bus database. So this bus database that I've configured, and I'm just going to select connect. So now I'm connecting to that database. Of course, that didn't quite work. Try one more time. Okay, let's see why we're having a little bit of technical glitch. Bear with me one moment, folks. We'll get connected to this hopefully. Okay, cool. One of the great things about SQL Notebooks is that it stores your results. So if you have any issues, like in live demos, like we're seeing right here, all the results are stored, so I don't even have to run these cells. Of course, it worked just 5 minutes ago, but that's okay. Okay, so the first thing we're gonna do is we're gonna clean up our environment if we have any existing temporary tables. That's what these hashtags kind of represent. And what we're going to do is we're going to look at what the data coming in is going to look like. So I just pulled two points from that real-time data, And you can see we've got direction, route, vehicle, position, some nesting here with latitude and longitude, as well as the time. And we basically have that for 2 buses. So this is 1 bus entry, this is the second. And we're just declaring this as a payload so we can see how to insert it. So I can basically take that information, use the open JSON from that payload, and choose how to store it in SQL format. And then on top of that, I can select it. And here's kind of the interesting geospatial support capabilities is I can take this and use the geography point to take in the latitude and location and store it as a location type of variable. So you can see how easily we can take in JSON. And if we take a look at that temporary table that we created, you can see we're able to turn that JSON data into a table. It's a little easier to read, but also we notice that that location is stored differently. So not much to show here about JSON at this point, just that it is supported, and that's kind of the big thing. Now, if we look at the geospatial part, we can take that location and use the verbiage toString to kind of take a look at how we took this kind of serialized value and turned it into a point. Now, what we can do is this is the latitude and longitude, and this is the format that we need. So for example, I can go into this OpenStreetMap playground. So this is open source, free to use. And I can basically just paste in the point and click plot and zoom out a bit. I think my bus is very small. And you can basically see, okay, like here's that bus. And if I zoom out really far, you can actually see, you know, this Bellevue, Seattle, and Microsoft's campus is over here, by the way. So if I wanted to create a geofence, so to say like, hey, I'm leaving work, I want to know when the bus is on campus, I can simply come in here, select polygon, and build a polygon around Microsoft's East Campus. Of course, we're not actually going into the office these days, but if we were, you get the point. And create this polygon, and what this does, actually I already have the point in here. So you see we have the point and the polygon, and so this is represented as a geometry collection. So you see it just has a point and a polygon, and then the coordinates that make that shape. So this is cool just for any development that you're doing that requires location. It's very easy to use. But you might think, okay, so we've looked at some of these points, we understand how to create polygons. And when I refer to a polygon, I'm probably going to say geofence from now on, because that's kind of the term to say, well, it's like a location fence. So you might want to be notified when something comes in or out, or how far something is away from it. Okay, so coming back to here, we think about geospatial, you have 2 buses. One thing you might want to do is figure out, okay, well, how far apart are these buses? Or in any scenario, how far apart are 2 objects? Very easy. With SQL, you basically take in those geographies and just use st distance. So the distance is basically bus 1, st distance, bus 2, and get the distance in meters, which we can see is about 400. Now, another thing for this scenario and maybe other scenarios, I was just talking to someone recently about this, about like a banking application where you're trying to find the closest ATM with no ATM fee. But in many scenarios, what you might want to do is understand when a bus or when something enters or exits a geofence, or if a bus is actively within a geofence. So again, this is something we can do very easily with SQL using geography. Oh, sorry. So this is actually, I got ahead of myself. This is actually just creating the geofence and storing it in SQL. So remember I showed you the polygon. This is a different polygon. This is actually closer to the bus that I might take to get to work. So you can see this is the geofence. And so we're going to try to figure out if a bus is in this geofence. So the first thing we have to do is store the geofence in here. So that's what we're doing here. We're just creating the geofence from the polygon, and you can see it's stored similar as location was before. Now, now I get too excited. Now we can use this this collection here. So we're basically creating a collection. Remember, I told you a geometry collection is a combination of multiple things. So what we have here is we have a point. So this is the location of a bus. And we have a geofence. And then very simple, just use st within to figure out is the point in the geofence. And so we can see that geometry collection here, and it's basically giving us a 1 or a 0 for if it's in the Geofence. So quickly, let's take a look and just confirm that this did that correctly. So here's the bus down here, so you can see it is not in the Geofence, and it correctly says 0. Now this one we would expect to be in the Geofence, and sure enough, it's right in the middle of the Geofence. So this is getting us on our way very easily without having to do any intense coding, really. We're just processing the data of if something's in the Geofence. Now later, we'll use some stored procedures to actually automate this. But for now, that's what I wanted to show you. So we've talked about JSON, Geospatial, Azure SQL Database. My last kind of thing about Azure SQL Database, and then we'll go full code, is to talk about serverless. So a lot of times when you're developing new applications, or you're using applications and you're not sure, like, is this thing going to take off and be very popular and need like a lot of compute, or is it just going to be kind of like slow to start and maybe intermittent in usage? Maybe it's just a line of business application. So serverless is really great for these scenarios because it basically allows you to set the min and the max compute for a given database, and then we're going to auto scale you on a per second basis and only bill you for what you use. And we're basically auto scaling you to the max of CPU or memory, whichever one is higher. Then we'll bring you back down and only bill you again for what you use. So this is truly a serverless model like you might see with something like Azure Functions, which we'll also talk about. Now, one of the benefits here is if you set an auto pause delay, here you see it set for like 2 hours, then after that 2 hours of inactivity, we're actually going to essentially shut down SQL Server and Azure SQL Database. You're only going to pay for storage at that point, and I'll show you in a second, but the storage is cheap, right? It's the compute and the server that is, runs up more of the bill. So serverless is really great for this, and I want you to know that it's not just, Azure SQL Database isn't just for serverless. We have other options that are available. This is my dog. We have other options that are available. And so let's say, you build this catching the bus application and it takes off and you just start, creating so much data, you need more storage. What you can do is you can leverage something called Azure SQL Database Hyperscale. And I'm not going to get into this, but I felt like I had to call it out. If you're not familiar with this, the technology here is just incredible. The team basically took apart a standard SQL engine and put it back together to be cloud native. So it has all these different caching layers, which basically allows us to scale to essentially a limitless size. So you're no longer bound by the size of the hardware or the limitations of the hardware. We can just scale up to 100 terabytes, and in theory, there's really nothing stopping us from going bigger than that. So know that this is available, and this is really cool technology. So if anyone is interested in this, I can definitely share some more information to read. We have a few white papers that are very interesting. For now, let's just take a quick look at serverless. So back to my VM, I'm going to go to the Azure portal. So again, you recall this was that bus server, my bus DB, and we can click into here. And what we'll see is that this is a serverless database, and you also see some options up here too. But this is a serverless database. You see the min and the max cores I've set, the auto pause delay, and here's the cool part. The storage cost per month is $5. So this is, pennies if I'm not using it. And, otherwise I'm going to be billed on a per second basis at this rate. Of course, these costs will vary based on region, but for the most part, you can see how and why this is getting such strong adoption from our customers. The other thing I can show you, if we go back to the overview of this database, I can take a look at what I was billed for. And this is, I just feel like, is an interesting kind of example of how serverless is great. Okay, so when I first started working on this application, you can see I wasn't really using it that much. I was just kind of like playing around, working on some things, then I wouldn't touch it for a few days. And I actually wasn't billed for any CPU during these times where this database is paused. You can see that. And when I was using it, it was billed on a per second basis. Now, once I got my application up and running, I was making constant connections to this thing. So that's something to keep in mind. As long as you're keeping the connection open, you're going to be billed at that minimum CPU required, but still very interesting, great adoption here. Okay, so let's go back and let's start talking about some other things. So we've talked about all these things. We now have our database set up. However, we need a way to get the data from the buses into the database in a scalable way. I just showed you a kind of small example of how we could take 2 buses, but we're going to be processing a lot more than 2 buses. We also need a way to send notifications. Remember, part of this was to send me a notification when my bus, my specific bus, is entering or exiting the geofence that I'm monitoring. So to do that, we're going to use an Azure function. Now, Azure functions are basically like serverless APIs that are hosted in Azure. Very easy to use and deploy. There's lots of extensions for them in Visual Studio Code. Also has backings for things like GitHub Actions, so you can do DevOps really easily. And then Azure Logic Apps, this was something I picked up recently. I haven't done a ton with it. It's super easy to use this, but I was basically able to drag and drop, create this like, hey, if I make a request to this thing, then send an email in Outlook or Gmail. So let's take a look at that. All right, back to the VM. Let's see, where do we want to be? Let's go to Visual Studio Code. Okay, so this is Visual Studio Code. Again, looks very similar to Azure Data Studio, but this is Visual Studio Code, and what you can see over here in my files is under this Azure Function folder, I have a .NET folder, and here's my get bus data function. So I have the function name, I have the timer trigger. So what this basically means is say run this function every 15 seconds, and this function basically awaits process bus data. So if we take a look at what that is doing, let's see, we can see it has a few things that it needs. So for example, the connection string to Azure SQL Database, the real-time feed URL, so that's that publicly facing King County publicly available real-time data, and then the logic app URL, which we're going to trigger at certain points. Now, in process bus data, we're going to get the real-time feed. This is pretty simple. We're just calling that real-time feed URL and storing the result as a feed. And then we're going to get the monitored routes. So I can see this one, it's making a SQL connection. So you can see how easy it is to get connected. And then we're basically saying, hey, run this stored procedure called get monitored routes. Now, what that does, if I just hop over here, hop over here and show you, is it's going to basically return the routes that I'm monitoring. So in this case, I'm monitoring this route 100.113. Then if we head back, the next thing it's going to do, just make this a little easier. The next thing it's going to do is it's going to take that feed in and find all of the buses, and then it's going to find the activated geofences. So what does that mean? It basically means it's going to do what you saw earlier. It's going to take in that JSON data, and then for each entry of what we're calling bus data, we're going to use this stored procedure add bus data with the payload to basically add that data very similarly to how we did with temporary tables in the first demo, but this time we're actually going to add it to the database. And we're also going to do this if they're activating a geofence. So what does that mean? Let me just show you just a few things here. So this is the stored procedure that we're calling. We're basically inserting that bus data using OpenJSON, so just like you saw in the first demo. And then we're going to find the geofences and figure out if it's entering or exiting, figure out if a bus is entering or exiting a geofence. So that's the big thing we're going to do here. We're also going to keep a log of the active geofences, and then we'll also store that historically, and we can do that with version tables. And finally, we're only going to return information about the buses that have entered and exits. If it's just consistently in the geofence or consistently out of the geofence, we don't need to return that data because that's not going to result in any sort of notification. Okay, oops. So basically from there, what we're going to do is for each of the activated geofences, or all the buses that are active in the geofence, we're going to trigger a logic app. And this logic app basically calls the logic app URL with the route and the status. So is it entering or exiting? So if we take a look briefly at that logic app, first of all, you can see the Azure function is running here. So you can see some of the results. It's kind of looking if buses are activating a geofence, if buses are in monitored routes, and some other information like that. But if we want to take a look at the logic app, we can see how easy this was to set up. Basically, when an HTTP request is received, so when we call this URL, we need to call it with value 1 and value 2, which is our route ID and our status, so if it's entering or exiting, and you could make an argument that I could label these better. And then after that, we're going to send an email. So this is really cool. I'd never used this before. It's really easy to like set up Outlook to send an email. So it basically says, you know, it takes in the route value 1 and the status value 2 and sends an email, also puts it in the subject. So, you know, you don't have to go actually open the email, you just get the notification and you're good to go. And so if we take a look, let's see if I got any emails. So looks like my bus hasn't come through recently. Let's see if I refresh this, if we have any new mails. We don't have any new ones, but you can see, for example, not that long ago, I did have a bus that entered my geofence and we would get a notification like that. Okay, so that is Azure Functions and Logic Apps. So if we take a step back and think about our application, we've figured out this notification process. We're using .NET and Azure Functions to basically manage getting data into our database and also triggering these notifications. So the last thing we might want is some like front end type of thing, web application there where people can go check and see where the buses are. So maybe they're not in the geofence, but I'm trying to figure out, okay, is there a bus kind of close by? Is it coming near? Or is it in the geofence and I missed the notification? So for that, we're going to use Azure Static Web Apps. Now, this is something relatively new, and it's a big value prop. Actually, there's a few, but its big value prop to me is that it's combining static content. So in this case, we're going to use a vue.js front end, but you could also use HTML, CSS, whatever, with an API. So basically, you saw an Azure function before, but now we're going to be able to deploy this one thing that combines the Azure function and the static content. So that's really cool. And what it also does is it has built-in GitHub action integration. So that means anytime I push, when I actually deploy this thing, it's going to spin up a workflow file for me, which basically tells GitHub Actions what to do to build and deploy and check this thing. But anytime I push or do a pull request, it's going to push it up to the repository and run through the build process that's there. So this is really useful for continuous integration, continuous deployment. So if we look at our architecture diagram, this is what we have so far. Now what we're going to add with this Azure Static Web App is another Azure function, which is basically going to request the data that we want to show in the application. It's going to be a very simple map application. So you can see the geofence and all the buses. So we're going to use an Azure function written in .NET to kind of get that information from Azure SQL. We're going to display it in our Azure Static Web App, and then we're going to have this website for monitoring active buses. And we're going to use GitHub Actions to deploy it all. And by the way, GitHub Actions is really cool. I'm a big fan. We're actually going to use it to keep our other Azure function up to date with another workflow. And we're going to use it to keep our Azure SQL Database up to date. So you can actually use workflows here in a SQL action to do that. Okay, so let's take a look at what this looks like. So I'm going to go back to my VM. We're going to go over to code. So here I am back in Visual Studio Code, but instead of looking at the Azure function, let's just look at the GitHub workflow. So you can see there are a lot of workflows here. That's because, like I mentioned earlier, we have this application available in .NET, Node, and Python. So you'll see different deployments for that there. For .NET, let me just make this one bigger in case it's too small. what you can see is we can name our workflow. We can see it's going to happen on a push or a pull request. And then we're going to run this build and deploy job. And what that's going to do is it's going to use some GitHub actions. Oh, here it is. Actions, Azure Static Web Apps deploy. So this is a specific action built for Azure Static Web Apps. It's going to take in a few things about our app, like the token and my GitHub token. And by the way, if you deploy this through the portal, it configures all of this for you. Then you just have to configure where your client is located. So in this case, where your front end is located, and then where your API is located. So you can see over here under Azure Static Web App, I have my API and client. Under API, since it's in multiple languages, I'm going to the .NET one. And yeah, that's basically it. It's pretty straightforward. They make it really easy for you to use. Similarly for Azure SQL Database, there's a SQL action, and it's using a DAC pack in this case to basically redeploy the schema. If you make any changes, it will update that here, and it just requires a GitHub secret of your Azure SQL connection string. And finally, for the function, you can also do this for the Azure Function. We see it here, and it resolves some dependencies, and you can do some custom stuff here if you want, and then it deploys it. So that's GitHub Actions, fairly straightforward. Now let's take a look at the application. So if we take a look at the client, again, this is Vue.js. It's using that OpenStreetMaps. And the important part is here. So this is how we're going to call the API. So we're going to call the function that's integrated into this Azure Static Web App. And these parameters is how we're going to get the route ID and the Geofence ID. So we're going to need the route ID and the Geofence ID to basically process where the Geofence is and where your related buses are. Now this client is just going to request that from the function, and it's going to plot that data. So it's pretty simple. And if we take a look at the API.NET, you can take a look at this function. And again, this is a pretty simple script. Basically says the function name, the route. So again, we said bus data. We're going to have two parameters, the route ID and the Geofence ID. And then we're basically going to make a connection to Azure SQL Database and run the get monitored bus data stored procedure, supplying the route ID and Geofence ID. So if we take a look at what that's doing, back in Azure Data Studio, we can see this stored procedure takes in those two items. Get a little bigger. And then it's going to get the latest location of all the buses in a route, find the ones closest to a Geofence, really just take the last most recent 50 points. We don't need more than 50 buses up on our map. That's not going to be useful. And we only want the ones that are within 5 kilometers of where we are. And we can do that using this D less than 5,000. And you can see how we're doing this using the geospatial support that's built into Azure SQL Database. Okay, so that's what our app is doing. So it's basically returning that information, and then back in the client, we're just going to surface that using plot WKT. It's pretty straightforward. The code sample is all here. It was a pretty easy lift. Okay, now let's talk about the GitHub and the workflows again, just briefly. Now let's say I make some change. So I'm just gonna make a silly change here, and I can go over to source control and say small change. So this is connected to my GitHub repository. I can commit that and basically push it up. Now we'll take a look at what this is done, but what it's basically going to do is it's going to look in this folder and kick off all of these workflows. Okay, so while that's going, let's take a look at this application. So here's my bus app. It's a static web app. Again, we can see various information about it, like the URL for the site, as well as the source code, which is in GitHub, as well as the deployment history and the workflow. You can actually edit it from here. So we might choose to go into the GitHub action runs, and you can see, sure enough, we're kicking off this small change. So we're able to see some of the things that are happening. Since it's in progress, what I'm going to do is take a look at the one that I just did. So we're going to do the Azure Static Web App CI/CD for .NET Function. So this was a test I ran earlier. basically what it's going to do is set up the job, build out the container, and then run the action. So we can look at build and deploy to see, I know this is a little small, but to see some of the thing that it's doing. It's finding the app and the API, and then it's using Oryx to help kind of detect the platform and build it out. So it noticed what version of .NET we're using. It's going to download it. It's going to collect some telemetry, and then it's going to push the projects to restore, build and restore, and prepare the output. And then we'll just do some post-run things like closing the, cleaning up and closing the job. But you can see how GitHub Actions is doing a lot of the legwork for me. All I did was just kick this thing up. Now, the last thing we might want to look at is the actual application. So let me just go out of full screen for a second. So this is the application. We can give it a good refresh. And what we can see is these are all my active buses on my monitor route. You see up here in the parameters, I'm specifying the route ID and the Geofence ID. And then here's my Geofence. So I can see that, you know, some buses are coming or leaving, are relatively close to my Geofence, but I haven't gotten any notifications yet because they haven't gotten here. So that's why you can see I don't have any new emails on this. So that's this application. It's relatively straightforward. You know, it was a lot of fun to build, so I hope that it serves useful for you all. We kind of, Davide and myself kind of pieced some things together, and it was really interesting, fun experience, and I think it's going to apply all these different services to other applications you would build. Again, not just catching the bus, which is a fun example, but I also like challenge folks, you know, because I'm sure people are not all joining from the Seattle area, especially given the name of the conference. But I challenge you to go look for similar bus data for your location, something close to where you live. And, you know, if you can fork this repo and make it work for your application, I think that would be pretty cool. So that's my challenge to you. Otherwise, just go check it out. So the URL for the code sample is just aka.ms/catchthebus. So over here, you'll see this code sample, the same code sample that you saw earlier. You know, Davide and I have been working on this. And the thing I'll say, coming soon, still working on it, is we're working on a complete learning path that's going to be free. So basically you can deploy all these Azure resources for free and get kind of step-by-step guidance. We're working on that. It's not done yet. And then the other shameless plug I'll give is I host a show on YouTube called Data Exposed. We stream live on Wednesdays. And we also release like pre-recorded episodes on Thursdays, but it's a lot of fun. We talk about all things data and how it relates to development in many cases. And yeah, I just had such a great time. I hope this was interesting to folks.
Definitely.
And good. Hey guys, what did you think?
Yeah, it was awesome.
Very much enjoyed the way you presented like the business scenario, and then how you explained the entire architecture and infrastructure and the mapping of the components you can use to make that business vision reality. So,
yeah, definitely. And I think like it's a good call out that like the .NET skills that people have are super relevant when we go to the cloud. So it makes all of these things much easier. Like none of the .NET code here was difficult, but it was able to kind of allow you to piece these things together very easily.
And then you also answered one of our questions, because some people from the audience were asking whether this Git repo is public and they can play with it. So it is.
Yep, it's very much public. Yeah, and if you have any issues with it, I would encourage you to let us know.
Okay, we'll do that. What was the topic yesterday? Yesterday was Wednesday.
Oh, on the show?
Mm-hmm.
Yeah, sure. Yesterday. Wow, it was so long ago. Yesterday on Data Exposed Live, what did we cover? Let me think.
So look, if you ask me what I did yesterday, I cannot answer really. So if you ask me about the session yesterday, so of course I remember most of them, but I cannot say the order or.
Yeah.
or
Oh,
words
you know what?
about
I got it. So yesterday, I have this mini series. It goes once a month with someone named Buck Woody. He's very popular in the community. And the show is called, or like the skit is something old, something new. And so this is a data science series. So we're taking data science from the beginning and kind of walking people through various things. So yesterday we talked about linear regression. That's what it was.
Cool. Our colleague Vlad, who's our AI specialist, so to say, would have loved it. We would recommend him to join.
Yeah,
us.
please.
But by the way, speaking of online shows and well, what's happening right now, what do you do in order to make the shows like a bit more lively, or because we're trying to steal experience from people that are doing similar things?
Yeah, I think it's a great question. And I think, you know, a lot of us are still figuring it out. Like, I wouldn't say like I mastered it. I only started this live part of the show in January. So, you know, we've been going live every week. We've gone like 12 times, you know, but I would say, you know, having more people on helps, like having people interact with each other. You know, I always interrupt. If I bring someone on, I interrupt them and I ask them questions. We do some polls, which is, you know, gives people a way to interact and engage. And also us as a speaker, you know, you're used to presenting to a room and looking at people's faces and seeing, you know, are they grokking it? Are they falling asleep? Are they, you know, on their computer? Like, you kind of get engaged. And so I think polls helps a lot. And then just trying to engage people, try to keep it fun, you know, keep your energy high. If your friend checks out our Data Exposed episode from yesterday, like, it's really funny. So we kind of try to make it funny, try to be silly, like try to keep people engaged. But yeah, it's definitely a challenge because there's so much going on all the time and so much to learn all the time.
Mm-hmm. Right. So
yeah,
I was
for
really
us it comes naturally because I'm funny and Florin is silly, so it's
yeah,
exactly.
It's a gift, man.
I was really impressed by the Ignite show this year.
Yeah.
Wow, amazing.
I'm glad to hear it. It's a lot of work that goes into those. I mean, personally, I'm hoping we can get back to being in person because I miss the other side of these conversations. And so.
Yeah. We feel you. And I'm also looking forward to the summits, which are really close. The RD summit and the MVP summit.
Oh yeah, those are coming up really soon. You guys will be there.
Yeah.
Awesome.
Yeah,
cool.
We're part of the community, so
wonderful.
Looking forward to that.
Yeah. Also, something about this because these 2 days are coming to an end now. But then, coincidentally, when you were zooming out and showing the map of the world, and one of our colleagues texted me that in these 2 days we had participants from 97 countries. So that's it's an achievement for us. Still a way to go because I think there are 190 something in total, but we're gonna get there probably.
Yes.
It's pretty amazing. Sure. Yeah, especially I'm guessing this used to be in person, so mostly you'd get maybe a few countries.
Yeah, indeed. So there are good things coming out of this.